When engineering students at Stanford took one of Bob Twiggs' classes, they learned how to make satellites, small ones roughly 1/2 meter in diameter. It was hard work, and students were challenged to get it all done in one semester. Bob reasoned that an even smaller satellite might make the coursework more manageable. Working with Jordi Puig-Suari at Cal Poly, the two came up with the basic CubeSat design that would eventually become the worldwide standard. The development of the CubeSat prototypes was largely done by academic groups. Initially, NASA showed very little interest, nor was there much interest from industry. Real satellites were big, often the size of a Greyhound bus, and expensive, and many experts at the time said a tiny satellite was the dumbest idea they'd ever heard. But the CubeSat innovators continued their collaboration. The CubeSat idea succeeded for three main reasons. First, they were built from mostly inexpensive off-the-shelf components, not custom-built hardware. Second, they were built to a standardized design and form factor, the CubeSat unit. And third, because they were small and standardized, multiple CubeSats could be launched and deployed together using an ingenious P-pod launcher to shoot the satellites out and away from the launch vehicle. In 2003, the first CubeSat was launched successfully from a Russian rocket. Once the concept had been proven to work, NASA and others were then willing to make room for CubeSats on orbital missions. Almost anyone could build and deploy their own satellite and test new ideas with very low risk. The universal acceptance of the P-pod launching concept was what led to the rapid growth of CubeSats. Advances in electronics design and manufacturing put even more capabilities within the CubeSat form factor. The original one-unit CubeSat form, a 10-centimeter cube, could be expanded so that bigger satellites were possible. In 2006, the biological CubeSat group NASA Ames Center launched GeneSat-1 to conduct biological experiments in space, the first science mission for a CubeSat. The success of that mission led to wide acceptance within the science community and NASA. In 2018, the first interplanetary use of a CubeSat came out of NASA JPL as part of the Mars InSight mission. Two 6-unit CubeSats served as communication relays for the lander as it landed on the planet's surface. Two commercial companies, Planet Labs and Spire Global, now have constellations of hundreds of CubeSats that they use to capture high-resolution imagery and Earth observation data used by business, academic, and government customers around the globe. And it all started with a teaching tool about the size of a Beanie Baby box that opened our eyes to the stars.